Welcome to this deep dive. We're looking at some really interesting material today. It's all centered around a paper called Mutarjim, Advancing Bidirectional Arabic-English Translation with a Small Language Model. And we've also got some related notes and sources you showed. So our mission really is to unpack this, cut through the jargon, and get to the heart of what's important here. We want to understand this new AI model, Mutarjim, and also a new benchmark data set they created, Tarjama 25. It's all about Arabic English translation. Think of this as, your shortcut to getting up to speed on this particular development in AI.
And it's definitely worth digging into. The sources make it clear right away that Arabic machine translation, well, it's not straightforward. The language itself has complexities that make it a real challenge for machines.
Yeah, the material really hammers that home. I mean, we've seen amazing AI progress with language, right? Especially these huge models. But it seems Arabic translation quality often kind of lags behind.
That's right. And the sources give us the why. You've got Arabic's really intricate grammar, its morphology, how words change form so dramatically with prefixes, suffixes, even internal vowels. It's not just swapping words, it's the whole structure. And then there are fundamental differences in vocabulary, sentence structure, semantics between Arabic and English. It's tricky to map meaning accurately.
Right. Not a simple copy-paste job. And according to the sources, the translation systems we've had for Arabic often, they struggle with all that complexity. Some are just limited. Others are parts of these massive multilingual models that might be okay generally, but aren't necessarily optimized specifically for Arabic.
Exactly. And those enormous models, they need huge amounts of computing power for training, for running, which makes them, frankly, impractical for a lot of real-world scenarios. Think resource-limited settings or stuff that needs to be near real-time. So that's where this idea of a smaller, more focused model starts to sound really appealing.
Okay, which brings us neatly to the star of the show today, Mutarjim. This is the model the paper introduces, positioned as a potential answer to some of these problems.
Yes, Mutarjim. It's presented as a compact, you could say small, language model, but it's specifically designed and optimized for translating between Arabic and English, and importantly, in both directions.
Okay, small in the AI world can mean different things. What are we talking about size-wise here compared to the big LLMs?
So the paper says Mutarjim has 1.5 billion parameters. Now, just for context, some of the models making headlines are easily 20, 30 billion parameters, sometimes much, much larger. So yeah, 1.5B is definitely modest in comparison.
And it's built on something called Kuwain 1.5B, an Arabic-centric base model. You mentioned decoder only. What does that mean practically?
Good question. So a decoder-only architecture is primarily designed to, generate text. It takes some input, like a prompt, and generates a sequence of words. For translation, you basically feed it the source sentence as the prompt, and it generates the target sentence. It's proven quite effective for these kinds of generative tasks, and using Kuwain 1.5B as the base means it already had some inherent understanding of Arabic structure, which is a plus.
Got it. Smaller model, Arabic-focused foundation built for generating translations. But here's the kicker, from the abstract anyway. Despite being small, Mutarjim apparently outperforms much larger models on several tests.
That's the headline claim, isn't it?
Yeah.
And it's what makes this interesting, that a 1.5B parameter model can go toe-to-toe with models maybe 20 times its size. And it does this while being way more efficient, computationally cheaper. The researchers argue it's not about raw size, but about a clever, tailored training process and really focusing on data quality.
Oh, okay, let's unpack that training approach then. The paper talks about a two-phase strategy. What was phase one all about?
Right, phase one. They call it translation-oriented large-scale pre-training. The basic idea was to build a really solid, balanced understanding of both Arabic and English together, like deeply bilingual, before zeroing in specifically on the translation task itself. Build that foundation first.
How'd they do that? What kind of data?
They took the base Kuwain 1.5B model and just kept training it, but on a huge amount of parallel data. We're talking about 10 billion tokens worth of paired Arabic and English sentences. This data came from public sources, like the OPUS collection, plus some of their own proprietary data.
And the method for this pre-training stage?
They used a standard technique called next token prediction, basically teaching the model to predict the next word in a sentence. But they added a smart twist. They used special markers, English and Arabic. These tags explicitly told the model, okay, English text follows, or Arabic text follows.
Ah, so it always knows which language it's dealing with in the sequence.
Exactly. And here's another key thing. For each pair of sentences, they randomly shuffled the order. Sometimes it saw English, then Arabic, other times Arabic, then English. This was crucial to stop it developing a bias towards translating better in just one direction. It forces that bidirectional capability right from the start.
Clever. Build a strong, balanced, bilingual base without favoring one direction. Okay. Then comes phase 2, targeted fine-tuning. What's the shift in focus here?
So now phase 2 is all about honing the model specifically for the task of translation. And they used a smaller data set for this, but one that was much, much higher quality.
What made it higher quality? Where did this data come from?
It was a curated set of about 6 million sentence pairs. Some of it started as machine translations from a top-tier LLM, but then, and this is important, it was meticulously reviewed and corrected by human language experts. They also used carefully filtered high-quality data from OPUS, again with layers of review. The focus was squarely on accuracy, fluency, naturalness.
So human oversight was really key for this fine-tuning data set.
Absolutely. The sources really emphasize that. And they were strategic about the data mix, too. They deliberately included more samples where Arabic was the original source language, roughly a 2-to-1 ratio, actually.
Why lean towards Arabic original data?
The thinking was to really boost the model's fluency and accuracy when translating into Arabic, to make sure it could capture the nuances and richness of the language properly. And the data wasn't just generic sentences either. It spanned a wide range of domains, general stuff, sure, but also medical, legal, technical texts, cultural references, even religious content, making it versatile.
Okay, it's diverse and quality checked. How did the fine-tuning itself work? The mechanics of it?
They used the same kind of formatting with the special language tokens as in phase 1, but they applied something called causal masking. What that means essentially is when the model was given a source sentence, say in English, it was only allowed to see that English sentence. It then had to generate the Arabic translation from scratch. It couldn't peek ahead at the correct target sentence in the training data. This directly trains the generative ability needed for translation.
I see. So phase 1 builds the bilingual knowledge. Phase 2 trains the actual translation skill using top-notch, carefully balanced data. Sounds very methodical. Now, the sources also spend quite a bit of time on this new benchmark data set they created, Tarjama 25. Why bother making a whole new benchmark? What was wrong with the existing ones?
Yeah, that's a fair question. The researchers basically argued that the existing benchmarks didn't quite cut it for truly evaluating complex Arabic-English translation. They pointed out several limitations, like many were quite English-centric, and they often relied on pretty short sentences, typically maybe 6 to 30 words long.
Which isn't always realistic, is it? Especially for more formal or technical texts.
Exactly. Real-world language, particularly in specialized fields, often uses much longer, more complex structures. The old benchmarks also tended to lack diversity in the types of text included, and there was this nagging concern about data contamination. The possibility that some test sentences might have accidentally ended up in the massive data sets used to train the very large models, giving them an unfair advantage on the test.
Right, like they'd already seen the answers. So Tarjama 25 is designed to be a tougher, more realistic test then.
Precisely. It's purpose-built as a comprehensive benchmark, specifically for bidirectional Arabic-English translation. It consists of 5,000 sentence pairs, all carefully selected and reviewed by human experts.
And did they address this sentence length issue? Are they longer in Tarjama 25?
Yes, that's a key feature. The sentences are significantly longer, generally between 50 and 100 words, much more representative of challenging real-world text. They also made sure it was perfectly balanced. Exactly half the sentences were originally written in Arabic and translated to English, and the other half were originally English translated to Arabic. True bidirectional testing.
What about the variety of topics?
Much broader coverage than typical older benchmarks. It includes general topics, but also medical, legal, technical, cultural, religious, and scientific domains. A real mix. And they were apparently very careful to curate it to avoid overlap with common pre-training data, ensuring it's a clean test set.
That definitely sounds like a more rigorous evaluation. Is it available for others to use?
Yes, the paper states Tarjama 25 is publicly released, which is great for the field, right? It gives the whole research community a better, more challenging yardstick to measure their own Arabic-English translation models against.
Okay, so we have Mutarjim, the model trained with that two-phase strategy, and Tarjama 25, the tough new benchmark. What did the experiments actually show? What did they learn about what makes Mutarjim tick?
They ran quite a few tests to figure out the impact of their various design choices. One interesting comparison was looking at unidirectional versus bidirectional training.
Meaning one model doing both jobs versus separate models for each translation direction.
Exactly. So while training a single bidirectional model, they call it Mutarjim is obviously more efficient resource-wise. Their experiments showed that creating dedicated unidirectional models, Mutarjim AR2EN for Arabic to English and Mutarjim N2AR for English to Arabic, actually scored slightly higher on some standard tests, like WMT24++ BED. For example, Mutarjim AR2EN got a Comet score about 3 points higher than the bidirectional one for Arabic to English on that benchmark.
Ah, so specializing still gives a slight edge for peak performance in one direction.
It seems so. Though they do point out that for a model Mutarjim size, the efficiency win of the single bidirectional model is pretty significant. So the best choice probably depends on your specific needs, maximum efficiency, or squeezing out that last bit of accuracy for one task.
Fair enough. What else came out of the experiments?
Well, they definitely confirmed the importance of that phase one pre-training step we talked about.
Yeah.
Trying to just fine-tune the base Quain model directly without that intermediate translation-focused pre-training, performance was significantly worse. So that big bilingual foundation was absolutely crucial. And importantly, it was actually feasible to do because Mutarjim isn't one of those giant resource-hungry models.
Makes sense. And you mentioned something about sentence length during training earlier.
Yes, that was quite revealing. They experimented with fine-tuning only on long sentences, like over 30 words. And while, yes, that improved performance on long sentences, it actually made performance on shorter sentences much worse. The model started, like, hallucinating or producing irrelevant stuff.
He got too used to being long-winded.
Pretty much. But the fix was interesting. They found that just including a mix was key. Adding even just 15% of shorter sentences, say 2 to 30 words, back into the fine-tuning data made the model perform well across all sentence lengths. It really shows how sensitive these models can be to the characteristics of their training data.
That's a very practical takeaway. Okay, let's get to the bottom line then, the evaluation. How did Mutarjim actually stack up against the competition on these benchmarks, especially the new Tarjama 25?
Right, the main event. The paper compares Mutarjim against a whole spectrum of models. Some smaller ones around 3 billion parameters, some big ones around 32 billion, and even proprietary systems like GPT-4 Mini.
A proper showdown.
You could say that. And the results on their own Tarjama 25 benchmark are, well, pretty striking for a 1.5B model. For English to Arabic translation, Mutarjim actually hit state-of-the-art. Across all the metrics they used, BLAU, GHRF+, comment, top scores.
Ooh, state-of-the-art on a brand new, tough benchmark with just 1.5 billion parameters. Against giants, that's genuinely impressive.
It really is. And for the other direction, Arabic to English, it also performed extremely well. It got the top BLAU score and was very close behind the much larger GPT-4 Mini on the other metrics, comment and GHRF+++ DAL. So these results strongly back up their claim. The targeted design lets it compete effectively, even punch above its weight class, you could say.
And did Tarjama 25 expose weaknesses in other models that maybe older benchmarks didn't?
It seems so. They noted that some models which looked very strong on older benchmarks, the ones with shorter sentences and maybe more English focus, their relative performance wasn't quite as dominant on Tarjama 25. It kind of highlights the value of having a benchmark like this that really pushes the models on longer text and genuine bidirectional complexity, gives a more realistic picture.
A truer test of capability.
Yeah. And one last interesting pattern they noted across most models they tested. Translating from Arabic to English generally scored better than translating from English into Arabic.
Huh. Why would translating into Arabic be the harder direction for most models?
The sources suggest a couple of things. Arabic's complex structure, morphology, and syntax mean there can be more ways to say the same thing correctly. Automated metrics might struggle to capture all that valid variation. Plus, many of the big multilingual models just have way more English data in their training diet. They're often better at processing English input than generating really fluent, natural-sounding Arabic output.
But Mutarjim didn't show that same imbalance as much, did it?
That's another key point. Its performance was more balanced between the two directions. And the paper credits this to that deliberate Arabic-centric focus during training, especially that 2-to-1 ratio favoring Arabic source material in the fine-tuning phase. It was specifically taught to be good at generating Arabic.
Okay, so let's try and boil this all down. What are the main takeaways for someone listening to this deep dive?
I think there are two big ones. First, Mutarjim itself. It shows you can create a compact, efficient model that delivers really powerful, even state-of-the-art results for a genuinely hard task like Arabic-English translation. And second, Tarjama 25. It provides a much-needed, more realistic, diverse, and challenging benchmark to actually measure progress accurately in this specific area.
Yeah, the headline really feels like smart design and high-quality data can let a smaller model compete with or even beat the giants using way fewer resources.
Exactly. It's a strong case for targeted approaches, not just relying on sheer scale. And the researchers do mention future plans, like maybe scaling Mutarjim up a bit, or training on even broader multilingual data to handle Arabic translation with other languages, maybe French or Turkish, while still trying to keep that efficiency focus.
Right. So, bringing it back to you, the listener, what does this all mean? What's the insight here?
Well, I think it really underscores something important in AI right now. Bigger isn't automatically better. Sometimes, a really thoughtful, specialized design paired with excellent representative data, the kind captured in Tarjama 25, can be more effective in a smaller package, especially for niche, complex problems like bridging the gap between languages like Arabic and English.
Okay, so here's a final thought to leave you with. If these results hold up, showing a relatively small focused model can be best in class on a tough, realistic test. How might that change where AI development heads next? Could we see more focus shifting away from just building ever larger models towards creating more specialized, efficient systems that are really aware of the context they operate in, particularly for languages or tasks that have these unique, deep challenges? What other fields or languages could really benefit from this kind of, let's say, quality over quantity thinking?
It certainly poses some interesting questions about the future direction of AI innovation, doesn't it?
It really does. Well, thanks to you for providing the source material that let us dive into this today. It's been a fascinating look at pushing the boundaries of machine translation for a really challenging language pair.